Hello and welcome to another video by George's Shed. In today's video I'm going to be introducing a new series of videos that I'm going to be doing. So as part of Shed Aeronautics, I have a goal of creating a DIY autonomous aircraft. So this is quite a big project, and before I get into it, obviously there are drones that you can just buy stock that are autonomous, so they will follow a GPS route and they can have GPS lock and stuff like that. But that is not very interesting for me because I want to get into the software and the hardware of actually developing my own system. So you can also buy semi-DIY systems such as the ArduPilot system. So this is modules that you can buy and plug into each other, and that will create an autonomous aircraft. But again, this isn't quite as DIY as I want. So I'm going to be fully creating my own flight controller system for an aircraft. So this, as I said previously, is an absolutely massive project to be undertaking. So I've broken it down into 6 separate steps/videos. So the first video, I'm going to make a two-way communication system. So this is going to use 2 Arduinos that can be able to communicate between each other very reliably and over a long distance. So to test this in the aircraft, I'm going to use this to relay battery voltage. So then moving on to the second one, I'm going to create a servo control system. So this will link into the receiver, the stock receiver on the aircraft, and we'll be able to manipulate it slightly. So this has a variety of ways, so I might have a separate switch on the Arduino that can control the flaps, which is separate from the transmitter. So this is learning how to be able to control all the servos on the aircraft using switches and stuff like that. So on the third video, I'm going to be using an accelerometer and gyroscope to be able to have an auto level mode. So this will be able to auto level the aircraft when the switch is flicked in both the roll and the pitch axis. So this is going to get us into PID control systems that flight controllers use, so we can start to get into how we're actually going to be able to control the aircraft. Video number 4 is going to be altitude hold. So this is going to use a barometer which measures air pressure on the aircraft to be able to hold an altitude. And this will I'll also be able to program set an altitude on a little LCD screen, so I can go up and down using a sort of autopilot system. So on episode 5 we're going to be using heading hold. So this is where the aircraft can obviously track a heading, and regardless of wind is going to be able to maintain that heading. So this is going to now start to use GPS because most GPS receivers have a compass on them. So it makes sense to buy a compass integrated into GPS. So this is going to help me learn how to be able to interface with the GPS and get that heading information. Then episode 6 is going to be full GPS integration. So this includes being able to have a GPS lock. So being able to circle around a fixed point, because obviously this is an aircraft, not a drone, or multi-rotor. So for example, fly around a single point on a field. Then this is going to move on to being able to fly to and back from a point, so this is sort of mission planning. Then being able to have multiple points and be able to fly there and back. And then finally, there's the finale for episode 6, we're going to integrate a landing system, so and return to home system. So you can manually fly it, say 5 kilometers away from the field you're flying from, and then flick return to home auto land. So it's going to spin around, fly to where it started, and sort of set up an approach onto a field. So that is going to be the 6 episodes that are going to create a DIY autonomous aircraft. So now what we're going to do is we're going to look at the aircraft I'm actually going to use. So I've actually already built this aircraft. Okay, so now I'm going to introduce the aircraft I'm going to use for this. So this is the aircraft. This is I'm actually giving it a name. Let's call it the Shed Explorer 2. That sounds quite professional. So this is a plane I built about a month ago, and it's had about 5 flights, with the longest flight being 20 minutes. So as you can see, this is a fairly simple aircraft built from foam board. It has a dual motor configuration and dual ESC configuration. It has 2 flaps, which currently have 2 positions. It's got ailerons, it's got a rudder, it's got an elevator. So this is quite a good aircraft. It already looks quite like a drone. So if I flip it over, you can see that it doesn't have any landing gear, it's just a belly lander. So you chuck it, and then there's this bump here to try and protect the props from snapping. Currently I haven't ever broken a prop, so it just sort of skids on here, belly lands. So you can see here's the bottom side of the wing. So on the inside it's got plenty of room, it's got a quite big fuselage. So if I just open up the main compartment, so you can see currently the receiver and all the servo mount point connections are back here, and then the ESC is up front. So this runs on 3 cell LiPo batteries. So this is one 5,500 milliamp battery, and this fuselage can fit 2 of them in the nose. So that is over 10 amp hours. Yeah, 10 amp hours of power of battery storage that this plane can take. So this plane is ideal for what I'm planning to do, because it's got a nice big section here where I can put all of the things in. It's also fairly big, as I said. It can have quite a decent capacity inside, so it won't get battered about too much in the wind. So it can fly at a semi-reasonable rate of wind. What I can also do with this is what I'm planning to do is have hard points to mount bombs to. So as part of the server control system, then later on the GPS integration, it's going to be able to autonomously drop bombs, which will just be obviously firm things. So that is the aircraft I'm going to be using. The nose also is interchangeable, so that comes off quite easily, like that. And so that can be replaced. This is just a simple nose cone that I built. I'll probably 3D print a replacement. So that's the end of this video. So please subscribe and like and comment, so you don't miss any of the future videos. Thanks for watching. Bye.